This conference will now be recorded.
I use at least 5 different online applications, and they're all a little different. So,
yeah, each of these online applications are a little different. Morning, everybody. This is September 9th, the OCP Coplate workstream. Today, we're going to do a update on the Universal Quick Disconnect specification. Also, just want to give a quick reminder that coming up is the Tech Week in November. Let's see here, I have it online. Is the November 9th through the 13th. And I'll go ahead and include the link for that in the minutes, but you can find that under the OCP website and go under events. And for the first topic today, Mark Springs is going to come and give the UQD specification update. This is preliminary, not reviewed, not final, whatever other caveats I need to throw at it. But we just want to get some feedback before we go ahead and submit it for formal review. When Mark's done with the review, we'll do a quick manifold update and a quick update on the leak detection. So Mark, if you're ready, you can go ahead and share screen on the bottom. And we'll
yeah, so I did share screen. Are you seeing my screen?
Not yet.
Okay.
Might be like Skype where you have to click yes 3 times.
Maybe. There is a little notice on the bottom of my screen says app.goToMeeting is sharing your screen. Does anyone
else see it?
No, I don't see it.
Okay. Let me stop sharing and I'll try this again. Okay.
And I've got the document up as well, so I could share it and page through if it doesn't work with you.
Okay.
Of course, I'm assuming it'll work for me.
How about now? Nothing?
Still not seeing it unless it's loading. Let me try.
Okay.
Application window, minutes. I thought I had it open. Okay. Can people see what I'm sharing? More importantly, Mark, can you see what I'm sharing?
Yeah, I can see what you're sharing.
Okay. Go ahead and just kind of guide me, scroll down, page down.
Okay, so this is the OCP Universal Quick Disconnect Specification Rev 1. I'll go through this sort of page by page. We can go as quickly or as slow as we need to, so feel free to stop. I'm able to read this in this mode fairly easy. Is this okay for everyone? Do we need to go wider screen or?
You can zoom in a little bit. We probably want a pretty good page.
I think it's good, Mark.
Okay.
It looks good. That's good.
Perfect. All right, so go ahead and scroll down, Michael.
I'll look at the table of contents, just dive into it.
Okay, yeah. I guess in terms of the layout, those of you that have seen the previous spec, it's very similarly laid out in terms of its contents. This is the taken the OCP template and use that. So it starts with a scope and interview, go through some terms and definitions, and then references and some license information. So the scope of this is, of course, the handmade universal quick disconnect. And if everybody's not familiar with that, it's the connector that connects the IT equipment to the fluid loop in the cabinet. So this is meant to be the handmade version. I go through 1.1, the terms and definitions of plug being the male side of the coupling, the socket, the female side of the coupling. the coupled state is when they're fully engaged and locked together. The poppet is on the plug side seal that translates when the socket stem pushes against it. The socket stem or valve stem is on the socket side, and it's a stationary part that presses against the poppet. The CV being the flow coefficient, one of the things that's one of the parameters that's used commonly with these types of couplings. Terminations are how the couplings are connected into the tubing or equipment on each
Quick
side.
question for
Go ahead.
Quick question for people on the bridge. Is the poppet and valve stem definition clear? At a quick glance, it almost seems like the poppet's pointing to the socket stem and then the stem's pointing back to the poppet, but is it kind of clear in the way that they interact with each other? Everybody's happy with the definition clear enough?
Yeah, those definitions actually.
Those are good.
I guess the question I have is are those definitions necessary for this specification? They may not be.
I guess, Mark, are there details discussed within your spec that refer to those terms often, or is it just a reference note in the definitions?
Yeah, it's not. I don't refer to them very often, so that's what as I read through it, I thought, oh, okay, maybe they're not necessary.
Mm-hmm. Yeah. The pop might be nice because that's not a very common valve stem. Seems pretty common nomenclature. I mean, maybe the combination's a little different, but yeah. Okay.
UQD, which I do refer to often, Universal Quick Disconnect. Break is the act of decoupling the plug in the socket. Go ahead and scroll down. Make is a term I commonly hear. It's the act of coupling the plug and socket so they're fully mated or locked together. Universal Quick Disconnect means fully interchangeable with other plug-in sockets that are made to this specification and of the same nominal size, of course. KPI, key performance indicator, and then I define the UQD02, 04, 06, and 08, and they roughly correspond to 1/8 inch, 1/4 inch, 3/8, and half. The terminations that go along with those UQD04s, 02s, and such, they're probably more like a UQD02 could be connected to a 1/8 inch tubing, or it could be connected to a 1/4 inch tubing. So they're a little bit, in terms of the sizings, they're sort of a rough size equivalent to the 1/8 inch. It would be hard to tell on the connector or the valves themselves, where the 1/8 inch comes from. But anyway, then I have a diagram showing some of those terms that I've used. You can see the socket stem and poppet are identified here, as well as some of the key features: the socket body, the plug socket seal surface, the terminations on either side, and then the plug body, and probably the most important feature, the locking feature on the plug side.
Mark, you mentioned a comment that you could have, like on the UQD02, different sizes of tubing. Or, how are you handling that in terms of, because the barb geometry can vary depending on the material and the diameter, obviously, the idea of the tubing. Are you giving specific part numbers for different solutions, or are you leaving that up to the end user?
So yeah, the end user would define their terminations. I do define one termination that's a minimum for this specification to have on each side, and those terminations are called out explicitly. Okay. But I think it's common for some suppliers to have needs, and I didn't want this specification to lock in the design on the the cabinet side or the IT equipment side.
Yeah. Thank you.
Mm-hmm. So section 1.2, key performance indicators. I've just identified some of those areas that would fall into KPI, flow rating, temperature rating, pressure rating, burst pressure rating. Go ahead and scroll down, Michael. Fluid loss on disconnect and CV value. And key performance indicators are measured parameters that key in defining the appropriate part selection.
And do you define the CV value somewhere?
It's defined in the terms above.
Okay.
If you want to scroll back up there real quick.
Yep.
Yeah. Section 2, feature and dimensional requirements. These are the physical feature of the socket shall conform to the dimensions shown in the figures and in the table. Likewise, the plug shall also conform to the dimensions in the figure and the table. Where there's no dimension given, the geometry is left to the discretion of the manufacturer and should be considered in user requirements for fit and function. Dimensions are given in millimeters. Figure 2, as you can see, identified some areas directly, like the angle, 35 degrees, also where the locking mechanism should be housed, and the surface where it's possible that O-ring gland can be located. And the rest dimensions are denoted by A, B, C, E, F, and S, with datum C and D. Okay, go ahead and scroll down to the table. Okay, I thought I don't like the table breaking in the page, but I'll have to fix that. So this is the UQD socket dimensional specification. The tolerance of those specific dimensions are along the top row there. You can see that dimension A would have a min tolerance. Dimension B has a plus or minus 0.25 tolerance. These dimensions are in millimeters. And so we'll go through all the dimensions, but you can see that if you scroll back up to the so dimension B, for instance, you can see as the UQD02 goes from the O2 size in the table to O4, that dimension increases. And so the diameter is increasing as you go down the dimensional spec. Okay. Any questions on that? Feedback, I mean.
And all dimensions are given in millimeters. That's called out in the paragraph above, right?
Yep.
Yeah.
Okay, go ahead and scroll to the next figure. This is the plug dimensions. Of course, this one has a lot more definition associated with it because it does have a locking mechanism or locking features in place. It's intended to either have a ball locking feature or a trigger lock, or whatever the next best innovation is relative to these types of couplers. But we do call a ball contact surface in the diagram so that it's understood that if you did a ball locking mechanism, it would be in that contacting that surface. That's important because there's a minimum Rockwell hardness required for that ball contact surface so you don't get galling and such. Likewise, the table's laid out similarly in that the tolerances go across the top of the page, and then the dimensions for each of these are called out in the table. All of these, just a note on these dimensions, they've been reviewed a number of times with our partner suppliers. So these dimensions I consider to be fixed at this point. You can scroll down. So section 2.1 terminations. Terminations, as we discussed before, are left to the discretion of the manufacturer. However, at a minimum, a barb termination on the socket and a straight thread O-ring boss termination on the plug shall be available as described in the below table. And if you look at the UQDO2, you'll see that we call out a barb to mate with reinforced EPDM tubing. An example of that tubing would be the Parker 804-4's tubing, which is a push lock tubing. On the plug side, I call out a straight O-ring boss per ISO 11926 and mating with a port also of the same spec, the -4 port. And so for each size, the UQDO2s, we're calling out a minimum option, essentially for the larger sizing of the tube you might be using for that. Okay, scroll down. So I call out here.
Sorry, Mark, quick question. If you go back to that, that's kind of an area of interest in me in terms of what I'm doing. So you guys specified the barb for a particular supplier's tubing is the idea?
As an example, so there's other suppliers that provide tubing that would also work, Eaton, for instance. So there's other tubing that would work with that. And then, of course, the verbiage on top, if there was a supplier that needed a particular tubing type or had a particular supplier, then they would work with the manufacturer of these connectors to make sure that would work for their needs.
So was it based off of a DIN standard, or did you guys kind of came together and agreed on a barb geometry?
There's no, so as you know, there's no real standard for that barb geometry.
Yep.
So when we received these based on the specification, there were differences definitely in the terminations. However, all of the terminations and the connections, held up in our validation testing, and so it would be expected that for whatever tubing that's being specified by the end user would work with they would work with the suppliers to make sure that would work.
Got it. Okay. Yeah, it's not a fun area. That's why as you know,
it gets complicated. Yeah. Yeah. Be cool if there was someone came out with an ISO standard or something for that barb geometry.
Thank you.
Mm-hmm.
Okay.
So section 2.2 latching requirements. So I'm calling out here that the locking mechanism, the latch or ball lock, would be housed in the socket and would mate to the UQD plug within the dimensions bounded by RG, P, and Q. The locking mechanism also must be utilized to meet the pressure and durability requirements specified in the document, and that is in the coupled state. Section 2.3, the outer envelope requirements. So if you noticed on the diagrams, I did not specify maximum dimensions for these particular handmade plugs, but I did. Yeah, go ahead and show the diagram. So, for instance, here you see there's a large diameter on the left-hand side, which would actually be the wrench flats in this case, and then on the socket side, and that's not dimensioned. And on the socket side diagram, if you look at that really quickly, Michael, scroll up. Yeah, yep. So you see there's no dimensions that specify the outer dimensions of the socket itself, which would actually it's typically the larger diameter within the mated pair. So if you scroll down to that section 2.3, you'll see that what I'm calling out here is a use case, which is a limiting use case, which is a 1U height understanding that these would be on the same, likely to be stacked on top of each other. So the supplier should understand that there's a finger access issue if the diameters of the parts get too large.
Mark, do you think it'd be helpful if you put like that kind of that zoned area, maybe a maximum, or is that something you guys tried to avoid?
We tried to avoid that because of the because that geometry it's a function of what they do internally. The suppliers are doing internally, and that internal geometry drives the outer geometry. And I didn't put that specifically because I wanted to leave space for some innovation in terms of what's happening on the outside of the plug. For instance, if for instance somebody wanted to do UQD that could also house some sort of a leak detect system or something like that, then there would be room for them to innovate in that space, even if you know, with the understanding that someone might want to use that in a 1U height.
And some of the designs too are fairly, I don't want to say isometric, non-symmetric. So the non-symmetric designs, will fit in that 1U space better, whereas they might technically be, if we gave like a diameter or something, they might be exceeding that in some areas. But overall, there's finger room.
That's right. Yeah, and some suppliers, of course, have the like a latching mechanism, a thumb latch. So that's an example of a non-symmetric part.
Yep.
Section 3, performance requirements, and so this is kind of the heavy lifting here for the spec in itself. So, and what I'm saying is in order to comply with, I got a typo over there. It says in order to comply with Intel UKD requirements. I need to change that, Michael. So could you take a note? I need to take out Intel UKD requirement and just put this document or something like that. In order to comply with this document, the coupling shall meet or exceed the performance requirements listed below. Section 3.1, the ergonomic requirements. So it's recommended to minimize coupling and decoupling forces for handmade connectors. See Table 4, ergo requirements. QD pairs shall lock together, and the coupled conditions recommend to have noticeable feedback to indicate the socket's latched. The parameters I am showing here are max coupling force. So what I'm asking for is the suppliers to publish the coupling force versus pressure. And for the latching mechanisms itself, it's recommended that they have some sort of visual, tactile, or audible feedback when the parts lock together. Okay. Section 3.2, shelf and service life requirements. UKD performance requirements should be met when exposed to the following life cycle. At end of life, shelf life requirements shown in Table 5, and service life requirements are in Table 6, and I have 5-year shelf life, 10-year service life, both required.
Hey, Mark.
Yes.
This is John. Quick question. I'm assuming that previous section is sort of requests the vendor to evaluate their seal material, because I'm assuming that's the main focus of this this section.
Of the ergonomic section, or the service life?
The shelf and service life.
Yes.
So with regards to the seals, right, and how they are dated in terms of when they are manufactured and how long they can sit on the shelf, and and then still get the 5 years of service life. Is that the understanding?
Yeah. So yeah, the seals would be a focus. Of course, all the mechanical, the mechanism, the whole thing would be included in that. It is the polymers that you're going to have to focus on to make sure you meet this requirement. It's both the seals and any suppliers that use polymer materials within their parts, and there are some that do that.
Hey,
Got it.
Mark,
Thanks.
further to that question, I mean, it is kind of confusing that the shelf life is less than the service life. So you might want to footnote that the intention is that it's the sum of the two, that you can have a product that sits on the shelf for 5 years and then it's required to have at least a 10-year life beyond that, right?
That's right. Yeah, that's true. That's a good
Because presumably
take
you
there.
could reverse it, right? I mean, you could have a shelf. If you met the spec, you would be able to put it on the shelf for 10 years and use it for 5 years, I assume.
Hmm. Yeah, no, that's a good point. We need to clarify that. Or, yeah, and it's not meant to say you can use it for 5 years, put it on the shelf for 5 years, and then use it again for 5 years. That would not be advisable.
Oh, really? Why not?
Because after you exercise the seals like that and you soak them, this polymer seal will get a compression set, and then if you dry that seal out, it's not good.
Wow. So if you leave the tubing in place after you remove a server and you don't replace the server immediately, you'll have a problem.
You don't want to dry your seals out after they've
Okay.
been used. Thanks,
Mark, hey,
yes, go ahead.
on that, another question, if you don't mind.
Sure.
For the combined 15 years, is this something that's usually offered by vendors, even for their off-the-shelf products?
Yeah, I don't know that it's published that way, but when we review this with the suppliers, um, for the most part, this fell in line with what their expectations were.
Thanks.
Okay.
So section 3.3 durability requirements. So the socket must withstand 5,000 make and break cycles. All performance requires listed in section 3, which is the one we're in, must be met or exceeded when the socket and plug are mated in the first times zero cycle and the 5,000th cycle, and at end of service life required by table 6 above. And just a note there, most of the suppliers actually go beyond 5,000 make break cycles in their testing. But Intel, we did some studies about what we would expect to see as far as make break cycles in a data center, and it actually is quite a bit less than that number. So
Yeah, I was going to say, Mark, that's pretty impressive. The stuff we're working on is much lower based on our information.
yeah, our numbers were much lower as well. Yeah. So the section 3.4 fluid loss requirements. So the fluid loss per couple and decouple shall meet or exceed the performance requirements given in the table below. 7. Fluid loss requirements to be measured with water as the fluid medium. So you can see there as we go from left to right with these flush face connectors, it is a function of the geometry in terms of how much spillage you could expect with the water, water sort of hanging onto the surface of the parts. So for O2s, you see we have a 0.02 milliliter going up to 0.07 milliliter at the UKDO8s.
Hey, Mark,
Mm-hmm.
can I go back to the cycle question real quickly?
Yeah, sure.
Why do we need that many cycles? If you don't want the seals to dry out, what's going to be the driver to have 5,000 cycles in 10 years?
So
it seems like if the industry has less cycles and we don't really need more, I mean, why are we going to such a large number of cycles?
Yeah, that's a really good question, and we did go back and forth on this quite a bit internally and with our partners. the two things. One, the partners felt like whether it was 1,000 cycles or 10,000 cycles, they were going to still do what they normally do, which is 10,000 cycles, which tests out, the durability of the parts themselves in terms of the surface wear and such. The use case, of course, is much less than that. Even when we tried to look at it in terms of putting margin on margin in a data center, how many times you were actually going to take these apart. So we sort of settled on 5,000, which is less than what they're normally doing. And the second part of that is we wanted to make sure we left room for, again, for the unknown, what the future might bring for these types of couplers and their use cases if they change. And so it was those two things that we kind of settled on 5,000, which is half less than they're normally doing, and the number we came up with, which I don't actually remember what it was. I would share it, but I don't recall. The high number we found in the data center analysis we did. Was that Glenn? Did you did an analysis on
So
your use case?
for us, we kind of used, we have electrical. So with Open Rack, right, we have bus bar connections, right. So if we're going to be removing a system to service it, we have kind of some specs based on the bus bar spec, and our data center folks and quality folks, we've kind of based our goals on that model. Because why would we make the coupling, significantly more than we spec an electric connector that has to kind of still function as well in the same rack. So that's where our numbers were kind of based off of.
I see. Do you recall what the cycles were?
Yeah, it's like 500 or something like that.
Yeah.
Much lower.
Yep. So, Dale, I think you asked that question. Was it Dale or John? Does that make sense in terms of how we ended up with the 5,000 cycles?
Sure.
Okay.
Section 3.5, the flow rate, pressure, and temperature requirement. The rated flow capability should be verified and published by the supplier. So we have a table here just with the parameters and the sizing going across to the right. And we have a section for priority, just meaning that would be called out if it was required or recommended in terms of these parameters. So we're designing these to operating pressures of 100 psi with a 3x minimum burst pressure on top of that. The minimum CV values are specified for each of the cases. And of course, in this case, suppliers meeting those minimum CVs, we have actually gone back and validated, verified that the interchanged connectors also meet these CVs. Flow rating, this is meant to be, you can see it's written at flow rating and at least this amount of flow rate for these particular plugs. We did essentially the flow rating here was calculated based on the ASHRAE recommended velocities for the sizings that we were looking at, and we wanted to make sure that we rated the couplers, the valves, for at least that flow rate, and that's what we did. We did update the flow rate for the UKDO2s. I think we dropped that down from a 0.8 to a 0.55 based on some feedback from our suppliers. So that's where we ended up. So also another area that's sort of highly debated is the operating temperature range. We settled it on 17 to 65 degrees and a shipping temperature with a wider range of -40 to 75. And as you can see, we have some footnotes here. The first footnote is relative to the, right there,
right,
is relative to the CV, just to understand that those were done with water. because specific gravity of the fluid, of course, would change the CV value. The operating temperature range, it's desirable to have a higher range, and this is kind of the I guess because we've gone back and forth a number of times on the temperatures and the limiting factor for materials used in the construction of these parts. 75 degrees kind of gets towards the transition temperature for some of the polymers that are used, and so we added that as a goal. Also, that those temperatures are based on some analysis that was done internally for maximum expected temperatures that might arise in a system. And then shipping could include charge systems is the other caveat we have there for the shipping temperature range. So moving on, section 4, marking requirements. Am I doing all right on time here?
Yeah, I think we're okay.
Okay.
Leave 5-10 minutes for other updates.
Okay. So identification of the U key nominal size are required per the table, color and marking requirements. And the marking should be positioned per the discretion of the manufacturer, but on a visual surface of the plug and socket. The identification, we tried to go with the short IDs, UQD02, UQD04, 06, and 08. And then a color coding option at a minimum. We'd like the suppliers to provide blue and red identifications for hot and cold. Section 4.1.
You said it at a minimum, but then it's showing recommended.
Good point. That should be required.
This here should be required?
Yep. Thanks, Dale. So section 4.1, identification. Within the digital or printed catalog, suppliers shall identify products meeting these requirements as dimensional and performance requirements conform to OCP Universal Quick Disconnect UQD specification Rev 1.0.
Okay.
Hey, Mark, before you go from that, I mean, that relates to a question I had. If we wanted to specify these requirements in a procurement document, how would we reference it? And would it be the same reference? And then how would we indicate where it will be available?
So yes, you would identify it by the title of the spec, and this would work, this identification here. And then where it would be available, I'm not sure I understand.
Well, is there a link that will have the current specification sort of into the foreseeable future?
Oh,
or
gosh,
would they get this from OCP? Generally.
It's going to be available on OCP. I'm not sure how that works actually. That's maybe a question for Michael or Jessica.
Yeah, we'll have to discuss that while we're formally reviewing it. So
yeah,
this is like the informal pre-review.
Yeah, and I know that Intel publishes a design guide with all these pointers would be in there, so that Intel's customers would have direct link to it. But I'm not sure where else people would have access, except OCP, of course.
You can always partner with one of the standards organizations that'll charge $50 or $100 to get a copy.
Okay, good to know. So section 5, wetted materials. I'm not sure why I have in addition there, Michael, at the beginning of that sentence.
Let's remove it.
Yeah. So wetted materials should be compatible with Dow Chemical Dow Frost L55 and Huntsman Chemical Jeff Cool ISF 55 coolant fluids. Suppliers responsible to confirm all materials using the UQD are compatible with the coolant fluids above and within the operating parameters specified in this document. If coolant fluid is other than stated above, or supplier should confirm supplier should confirm the materials used are compatible with end user fluid chemistry.
Mm.
Hey, Mark, this is John again. Any reason why specifically the focus on the 55% and not or not just specifying a range? Because I remember from an ecosystem building standpoint, Intel was recommending both the 25 and the 55, right?
Right.
Is there the reason why you're recommending the 55 is because it's more severe than the 25, or?
No, actually, they would be the same from a compatibility standpoint.
Right.
So no.
Or potentially the 55 could be easier to implement because it's naturally biostatic at such a large concentration, right?
It
So the
is.
additives may be less in the 55 compared to the 25. I don't know. I'm just curious. It's
Yeah,
very
no,
interesting.
that's a good question, and I don't think that. I think in this case, either one of those designations would work. I think the 25 probably actually to me makes more sense, but I'm going to circle back with our materials guy, Sean, and make sure we're stating this correctly.
Awesome. Thank you.
Yep. Good question. Thanks. Sections, go ahead. Actually, section 6 is up a little bit. Yeah, safety and regulatory requirements. We're still waiting on our safety and regulatory folks to come back and see if there's any feedback here in terms of if we need to specifically name some safety and regulatory requirements that would be needed sort of across the board. Section 7, acknowledging folks that have had input or review of the document. And then I'm referencing in section 8, the ISO 18869 test methods.
Okay.
And that is the end of the document.
All right, any other questions, comments? Not, thanks for bringing that in, Mark.
Good job, Mark. Looks good.
Thank you.
Yeah, looks good.
Thanks for sharing.
Sure.
All right, do we have anyone from the manifold or V3 section? Glenn or anyone with a quick update? Hi, Glenn.
So do me a favor, in the future, can you refer to the group as the Blind Mate Interfaces group, because it caused some confusion actually on some other discussions. I know you're not doing that on purpose, but
No.
Someone sent me a note saying specifically about a manifold question, so just FYI. Thank you. So yeah, I can give an update. So we released the first version of the proof of concept for the 5mm blind mate quick connectors. They're being built. We should be getting them in this month. We all agreed on a basic test plan on reviewing these. It's not quite as stringent as it would be, say, for the second round, since this is the first time everyone's building them. We're in the process of getting some racks in, and we're going to be building up some prototypes later in the year, depending on lead times on manifolds and what have you. But we're also working through, John's been doing a great job working with the suppliers on the manifold performance requirements, and we're in the process of kind of cleaning that up. And we're also doing some structural analysis with our rack suppliers that are on the call, as well as the manifold suppliers, because one of the challenges that I mentioned in the last summit, and that's making it, one of the challenges between developing these quick connectors is you have quite a bit of mate ports when you're talking about a blind mate valve and pressure. So we're working through those areas now. As you know, we had the white paper on the manual couplings and hoses best practices that was approved and published last month. We've got a group of 5 different speakers are going to speak at the Tech Week. We're organizing that now. So we're going to talk about, I'm going to give an overall update. We're going to have a speaker speak for the people doing the BlindMate Quick Connects, the manifolds, the IT gear work, as well as Jeff's going to kind of give an overview to the community on the white paper. So quite a bit going on right now.
All right, and let me share real quick, see if I captured all that.
I have a quick question. So when
Sure.
you get those parts in, I'm assuming you're going to be doing some testing on those. Are you going to share that test data?
We're going to, I think when I've got to talk with the community, much like you, right, we're running kind of a private group. So whatever we share, we've got to kind of agree on. So
Understood.
as much as I can say, yeah, Mark, we're going to give you specifics. We're going to probably share at the minimum, share whether we did what met our goals or we have improvements to make. But as far as the details, I can't speak on that. I have to let the group kind of decide.
Understood. Yeah. Thank you.
I don't mean to be so answer with a non-answer, but you know how that is with this group.
I get it.
Everyone has to agree. Everyone has to agree what we share. So.
Yeah. The prototype and testing, would you say that's for the Aura V3, or should I say that's for the BlindMate interfaces?
BlindMate.
And I captured the Tech Week in November. I think this was from last week. Move that, and I'm going to leave the note for the best known practices in there. Anything else I should capture for this week?
I think that's the main one. Those are the main ones.
Okay. All right. Last item. This isn't really new anymore, but leak detection. Prevention. So we're making detection. So we're making progress on the document. I brought in the outline a few months ago. Getting close to bringing in another rev of the outline, or maybe the next chapter for review. Just look at my notes. So expect another update probably in the next month. I'll bring in like maybe one of the next chapters, either definitions chapter or maybe the leak detection chapter. We've got a few more members, slowly expanding the group. And again, progress is being made. So expect another document, informal document update on this one coming soon. All right, do we have any other opens for today? All right, if not, that's all I have. Thanks everybody for calling in.
Thanks, Mark, for sharing.
Okay.
Thank you.
Thanks, Mark.
Thanks.
Take care.
Bye.